All right, gents, welcome back. We are back with the CCNA initiative. We've just completed chapter 7, which is, I believe, part 2 of this book, right? Of the CCNA 200-301. Please don't quote me on the part, so I may have it wrong. The more important thing, right, is we're moving up, right? The last 7 chapters, we discussing basic switch connectivity. We're going over mostly layer 1, touched on some layer 2 stuff, touched on layer 3, but not detailed, right? All the last 7 chapters are at a high level, okay? So, chapter 8 is where, um, if you guys played video games in the past, is where we start our journey to Hyrule Castle. Shout out to my homies that played The Legend of Zelda. Okay, so right with this video game, The Legend of Zelda, of course, you're gonna hit a lot of obstacles, a lot of things that are not gonna make sense, right? And this is right exactly what the CCNA is, right? You're gonna hit a lot of snags that isn't going to make sense when it's worded, right? Like I've told you guys before, please use multiple resources. YouTube University, different blog sites, compare, contrast, right? At least 3 or 4 resources. Reach out to your mentors, your friends, other people that's in the field, and confirm your theory, your thought, whatever is confusing, okay? With that being said, let's go ahead and jump on in, okay? So, chapter 8, implementing Ethernet virtual local area networks, or LANs, okay? So, OSI model, we're still at layer 2, okay? Just doing some housekeeping. Remember, TCP/IP stack, right? That's still layer 2 as well, all right? So let's go ahead and keep going, right? What is the goals, right? What are you going to accomplish, right? Whenever we go through this chapter, right? Quick disclosure, as always, right? I am not going to touch on all the points, right? It is up to you with the CCNA initiative to also do your part, right? To do your reading. I'm going to miss some part. I'm going to skip some parts, right? But here are the things you need to go ahead and take from chapter 8, right? Describe switching concepts, right? MAC address learning and aging, frame switching, frame flooding, what a MAC address table is, right? Configuring, verifying VLANs, right? The normal range, right? Spanning multiple switches. Tell me what an access port is, data and voice, what a default VLAN is, connectivity via layer 2 on VLANs, right? Configure and verify inter-switch connectivity, right? So we're going to talk about trunk ports, right? We're going to talk about 802.1q, right? We might look at the RFC as well for that one. So I think that might be out of scope, but not for me. So take you guys on a ride. And you guys need to know about native VLAN, not just for the CCNA, but absolutely for your future jobs if you're going to work in this field. Okay. So this is my friend, the switch, right? And we're going to be friends with this for this device for the next 4 chapters. Okay. All right. Let's go ahead and jump right in, right? So a LAN, right? LAN meaning a local area network, includes all devices in the same broadcast domain, right? From a high level, we're going to call a broadcast domain a classroom, okay? Right? We're going to go ahead and call it a classroom. You know what? I'm going to switch it up. We're going to call the broadcast domain a building. I'm going to go ahead and call it a building, okay? So local area network includes all devices in the same building, right? Or the broadcast domain, okay? Keep rolling. So my diagram, okay? Diagram is actually from Cisco. Do have to give them credit, but the diagram on the PowerPoint, right? Let's dissect this real quick, right? We have 2 buildings, right? Building 1 on the left has switch 1 in it, right? And they're their own local area network. Building 2 on the right, okay? It has its own building, right? It has its own switch, right? Switch 2, okay? All right. And that's its own local area network, okay? Local area network meaning, of course, when I say building, broadcast domain. All right. Stay with me, right? broadcast domain 1 on the left, broadcast domain 2 on the right. Okay? All right. So let's go ahead and keep going. All right. So what I was previously looking at, what you guys are previously looking at with me, right, is two devices. And let me go ahead and make sure I split this up, right? So two devices, right? We're going to assume nobody made changes to it, right? So um, we have our network engineer, Angelot, right? He's setting up these buildings, right? But he had to hurry up and get these buildings going and get everybody connected to the internet. So he just plugged these devices in, right? He didn't configure anything on, right? So right out of the box, right? No VLANs, right? And I'm going to get to what VLANs are in a little bit, right? You guys already know what LANs are, but there has been no configurations of VLANs or virtual local area networks, right? Okay, so everybody's on the same local area network. Okay, there's no slicing, there's no anything, right? Now, Angela had some time. He went ahead and went back and said, all right, so everybody that's in this building, cannot just be all in one room, one auditorium, teaching class, right? Because everybody's going to be talking above each other, or there's specific reasons why we would want to go ahead and break different people into different classrooms, right? Okay, stay with me, right? We're talking about a building, right? And we're talking about a school, right? So everybody's now teaching. Before Angela was able to set everything up, everybody's working out of the auditorium, right? It's loud. It's just a lot, right? We can work, but it's a lot. Okay. So what Angela wanted to do, he said, okay, let's go ahead and split everybody up, right? We have rooms, right? He got the construction workers that came in and built rooms. And with those rooms, we're going to give each room their own local area network. Okay. All right. So it'll cost a lot of money if he got every classroom their own switch. That'll be a lot. It'll be a lot, right? So what he did is he said, everybody's still going to connect to this device. What I can do is put specific classrooms in their own local area network. Okay? Right? But not by having different devices, right? Different switches. I can do it by virtually splitting them up into different virtual local area networks. Okay? Right? Because before, right? One switch is one broadcast domain. Unconfigured, one broadcast domain, one local area network. Okay? If he wanted to split everybody into different classrooms, right? If he went with the physical route, he went ahead and said, hey, I'm going to go ahead and give everybody their own switch. So it'll be their own local area network, right? Well, that's going to be a lot of money, right? What he can do, because there's not a lot of people in the building, right? Everybody can fit on this one switch. So what he's going to do is say, instead of splitting up my local area networks via multiple switches, I can split it up via one switch using virtual local area networks, aka VLANs. Okay. On the left, you see VLAN 1, right? So, Dino and Fred, they're on one part, right? They're on VLAN 1. Wilma and Betty, they're on VLAN 2. Okay. Right. So this is an example of implementing virtual local area networks. Okay. AKA two different broadcast domains on the same device, right? Let's keep going. All right. I'm not going to read all of this, right? Because I want you guys to read it on your own spare time. right? These are just one, I wanted to screenshot this, put this on the PowerPoint, because whenever we see a key topic, right? Whenever we're reading an official cert guide, you guys need to stop, breathe, and read what exactly the book is telling you you need to know for the exam. Okay? Let's keep going. So let's talk about this, right? We see two switches now, right? And we learn the concept of virtual local area networks, right? Where we're able to create multiple broadcast domains on one single device, right? But what happens now whenever we go ahead and have two devices, right? So we're still with the classroom example, right? Right? But more people have come into this building, right? So he has a switch of 48 ports, right? And it just so happens has 40 people, right? Another class has two classes has joined that building, right? So they're not going to fit on the switch. So he had to buy another switch, right? With that other switch, right? It's going to, we need to make sure it can communicate with the other switch, right? And how would we go ahead and do that? How would we, you know, communicate multiple VLANs between two switches, right? Because we can configure specific ports to say, hey, you're here, you're there, you're here, right? You're part of this broadcast domain, you're part of that broadcast domain, right? What can we do? Here's where the theory of trunking comes in, okay? All right, let's keep going. So, Angela, he gets a second switch, he connects them together, right? And so he wants to implement trunking, right? Because he wants to make sure, right? One, everything is connected and they can communicate. And also they can pass traffic, right? Even though they're on different switches, right? Because if we have a broadcast domain, right? Virtual LANs, right? Or VLANs on one switch, maybe 1, 2, 3, 4, and 5, right? Those are those classrooms over there. But we also need on the other switch, 1, 2, 3, 4, and 5 to be able to communicate over there, right? Because maybe teacher one needs to talk to teacher two, right? On the other side. So we need to make sure they can communicate, right? And they can pass traffic through. Okay. So what he is going to do is create a trunk, right? Now, what is a trunk, right? What does that mean? What is it doing? Right? So the use of a trunk, right? It allows switches to forward frames from multiple VLANs over a single connection, right? How does it do that? Right? All it's doing is adding a little header, right? That says, I'm part of this VLAN, right? In that Ethernet header, right? Because within that frame, right? Because we're at layer 2. In that frame, we have a Ethernet header, we have an Ethernet trailer, right? In that header, there is a section, as you can see on the screen, where it says 802.1q, right? And we'll get to that in the next section, right? And I'll show you guys that in Wireshark as well. But it's going to have, in that 802.1q tag section, it's going to have 4 things: a type, priority, a flag, and the VLAN ID. Okay? I wanted to show you guys this screen for a reason. So we have the trunk, right? We have multiple VLANs, right? And so with using trunking and adding that small header, if switch 2, right, which is, we're going to say that that's a switch 1, right? We're going to say switch 1 was originally the switch that Angela put inside the building, right? And he split up different, he made separate broadcast domains for different classrooms, right? 1, 2, 3, 4, and 5, right? 1, 2, 3, 4, and 5 also needs to communicate with the new switch that he's created, right? The other side, right? So teachers could talk to each other. So with him using trunking, if teacher A needs to talk to teacher A on the other side, right? And then those both teachers are in the same VLAN, right? We're going to say VLAN 2. What's going to happen, right, is when teacher A on switch 1 says, hey, I just want to say hi to teacher A off of switch 2, traffic is going to leave that computer, hit the switch, and along the trunk, right, it's going to tag, right? It's going to tag that Ethernet header, that frame, right? This is where tagging comes in. It's going to tag and say, hey, this is only destined for this broadcast domain. I'm going to tag it as such. It's going to travel over to the trunk, right? That other switch is going to get it and say, hey, it's for this broadcast domain. Let me go ahead and forward it out of all of my ports that are part of that broadcast domain. Okay? So at a high level, that's how VLAN tagging works. Okay? Right? And so this is just a synopsis of what I just explained, right? This is how VLAN tagging works. Okay? Let's keep going. All right? So we're going to go over this whenever I pull up the Wireshark example, right? Whenever we're dissecting this packet. And we're going to go real slow in this chapter, in this section, just because this is important. And of course, we're starting on spanning tree and a lot of layer 2 stuff, okay? So, like I told you guys before, a lot of these theory sections, I'm making them short on purpose, just because it's going to be a lot of information. So before we go ahead and leave, right, I just want to talk a little bit about 802.1q and ISL, okay? What are those, right? So 802.1q and ISL are different trunking protocols, right? ISL, of course, was created by Cisco, you know, many dinosaur years ago, right? And of course, we have 802.1q, right? That's standardized by the IEEE. Okay. So, of course, mostly now, right? Different vendors or what have you, they use 802.1q. And even Cisco is now, ISL still exists, but it's barely used on even their devices. Okay. So, like you see on this diagram, right? That 802.1q header, right? It has that 12-bit VLAN ID, right? And we're going to go over bits in the future, right? When, of course, whenever we have that lab session, I'm going to go over why, knowing, you know, how many bits, bytes, and all that, why that's important and what it means to go ahead and decipher that, right? But those 12 bits say which VLAN ID, right? Which broadcast domain this needs to be sent to, right? So please keep that in mind. All right. All right. So with that being said, and again, we're going to talk about native VLANs in the future, right? And how tagging doesn't happen on the native VLAN. We're going to talk about more about trunking and how the protocols work or what have you in the future. Okay. With that being said, I will see you guys next week for Lab Fun Day. You guys have a great day.